Yes, so my name is Anthony Varg, 2013 Nuffield Scholar, and my subject is rice straw utilisation and evaluating. Before I get into it, I'd like to thank RURDIC, particularly John Demandic. I actually went and spoke to him, he was a real inspiration for me, which was fantastic. Also Rice R&D, particularly Ian Mason and Russell Ford, who I'm lucky enough not to have any today, which is good. Catch up and stay late tonight. So I'd really like to thank them, and I'd also like to thank the Rice Growers Association of Australia. It's a small organisation, but the vision that Ruth Wade and Andrew Blom and the guys there saw in the need to build human capital into such a small, vibrant industry has allowed myself and others to do things like Nuffield and other human capital building programs, so I really must thank them. So a bit about me, 27-year-old, working on the family farm. We've got my brother Ryan works there, who's taken on a massive load while being away. We've got another younger brother Lockie about to come back, which is exciting. And my mum and dad have actually have come from New South Wales today to hear me speak up the back, so thank you Mum and Dad for coming down. It really means a lot, and this whole adventure for me has just been easy for me. I've gone off and I've seen these amazing things and talked to fantastic people, but it's the people back at home that had to, pick up the extra workload and deal with me going all over the place and not being around me at important times and things like that. So it really means a lot for the sacrifice they've made for me to be able to do this. And I'd also like to thank my girlfriend Rach, who I don't think she's here, I'm shopping, so she moved to Miami to be closer with me, and I thanked her by hopping on a plane and disappearing, so that was really good. So, why rice straw utilisation? A couple of reasons. Firstly, when I came back on the farm and I sort of noticed we're not using it, there's no value in it, straw and all that sort of thing, but there's got to be some use to it. There's some way we can hopefully evaluate it and get some value out of it. But the other big one, and probably that I see is more prominent, is unless you do something like this, rice straw burning is not sexy. It's an ugly thing that is very hard to defend. That's more what it looks like, and as Don alluded to, you can end up with days like this. And as a result, we start to see newspaper articles like that coming through. So, straw burning's been banned in the UK, in Europe. They're even banned it now in India, in Egypt, places like that. And they're high density population areas, I know, but we're lucky we're out in the sticks a little bit, but I see there'll be a point when we might get the tap on the shoulder, and so we need to have something that we can fall back on. The industry has done a lot of good things looking at proper burning management and things like that, but I think we need to start ramping up looking at other solutions. So why do we burn in the first place? Why can't we just turn it back in and utilise all that great LM? Well, we have 10 to 12 tonne crops, which equates to about 10 to 12 tonnes of straw, and that's just a biomass you just cannot get through and cannot deal with. So what we tend to do, a lot of growers do, we'll harvest. So long as we don't bog it all up, we'll then windrow it or roll it and then burn it, and within a couple of weeks we'll put a cereal or a canola crop in. And we're doing that to try and utilise the soil moisture left from the rice crop and achieve that double cropping. So I'll just quickly outline my key findings and then go into them in more detail. The great thing that I found was that there are solutions out there. There's not some hopeful thing that we might be able to think up. There was actual things on the ground that I saw that we might be able to adapt. And I'll go through all those in a bit more detail. The big thing I really found though was that it was the government assistance that was provided in those areas that led to innovation and change. A lot of the time it would have been government intervention banning things like burning, for instance in Punjab in India. But within 2 years, the progress and the development that had occurred as an almost necessity, with the government assistance tipped in, led to just some amazing change. So we're fortunate that we can look at the processes that occurred there and look at the possibility of utilising their mistakes and looking at how we can adjust. But there's two levels of the solution. there's an industry solution, or there's possible industry solutions for the whole industry. And there's also individual grower solutions that can more look at niche markets and things like that. So the first thing I came across when I went to California and talked to Glenn Nadar from the University of California was straw leach, which is essentially silage using straw. Now, people have tried in the past at home to do, adding urea and things like that, but the cost sort of outweighed and the nutritional value didn't seem to still be there. But what Glenn had found was there was 2 points that had to be baled early, straight after the header, usually within 24 hours, and the moisture content had to be between 45 to 65%. In some cases, you could even push it higher. And by doing that, it became a cost you carting a lot of water, essentially, but you needed a source of the feed, like the animals close by, to justify it. But from that graph, you can see the dry straw in the yellow, that was the control, I suppose, or then the control of the actual storage, and the urea in the HS, which is a commercial product, hay saver, and that ended up at a level that was equivalent of low-grade alfalfa or lucerne hay. So that really did give quite a good impression to me that we have a lot of dairies and feedlots close by, so that was a real possibility. So here's just a couple of photos of what they do. They basically stack up the rice straw, add a bit more water if they require. They usually put the hay saver or something in as they're baling on the baler. It's quite a tacky, brown, almost rotting looking product, but the cows, you can see in that bottom, your right hand side photo, they've got the strawage and then just, I think that was alfalfa hay or something, and they were going with strawage, so it looked quite good. Now, erosion control is something I didn't even comprehend, but when I got there, I came across, got talking to guys, and they were using it for a few things. But one was bushfire erosion control. After a bushfire in California, they worry about all sediment runoff and loss of nitrogen and soil loss and all that sort of thing. So what they were doing was getting the big Elvis helicopters with a big net, basically putting chopped up rice straw in them and flying them across affected zones and dropping about a tonne to the acre, or about an inch thick, across these areas, especially in waterways and estuaries. And it was hugely opportunistic, because if there's no bushfires, there's no market, but there was a few guys who were doing quite well out of it, and they were choosing rice straw because it's grown in an aquatic environment, and so the only weeds potentially that are in there are aquatic weeds, which don't have any long-lasting effects if they drop them into the mountainside, as opposed to a dryland cereal crop. There's also civil and construction sites that were using rice straw quite readily. A bit of a niche market, but there was a few growers who developed a product that was actually fully utilised and was in, you could see it within construction sites. There's also potential with ski resorts. A lot of ski resorts are using it as a bedding underneath their snow to try and provide longer lasting snow. But out of all this, there was less than 1% of the Californian rice straw used in this sort of way in evaluating. But there's just some photos of that, those sausages in the civil and construction game, and there's some revegetation on the mountaintop they're using to stop the runoff. Now the next one was mulching and compost that I looked at, and I separated, I'm not talking about in the paddock mulching and composting and things like that, because for my project I'm looking at the double cropping scenario, so I sort of stayed away from that side of things. So I more looked at how we could possibly remove the straw and do something with it to provide value adding. So this high silica content in rice straw compared to cereal straws can be an advantage and a disadvantage. It can be an advantage in that it takes longer to break down, so for gardens and mulching and things like that, there's a real possibility, but if you want to produce some sort of compost, obviously it takes more energy to break down, so it's a bit of a catch-22. And the other big thing was that the transport was the thing that always seemed to be the burden. It was about carrying rice straw bales about more than about 30-40 kilometres seemed to be the edge of the limit. Bioenergy was the big one that I got really excited about, and I was looking at that mostly on the tail end of my trip, and I thought I'll just look at these other things and just find that old silver bullet right at the end and job done. But besides the enormous industry potential we've got here, we haven't looked at anything generally across Australia. We heard from Guy with, there's limited things happening in Australia, but there is enormous potential in the rice industry. And there's two main modes, electricity and biogas. And the technology is constantly emerging. Things that were occurring 5 years ago, I went and visited a plant that said they were burning 100% rice straw in Punjab, India. And when I got there was a little tiny pile of rice straw in one corner, and then there was everything else going in the other side. So it was a bit disappointing, but then when I looked right into it, it was just they were using old technology, and there were modern technology that was evolving that could allow the silica, that's the main problem, to be basically removed early. And that's what I'm talking about, high value extraction, the key to success. So we're talking about removing the silica and hydrocellulose and cellulose, so that then the end product, we can sell those products on as high value, and then the lower value products we can justify burning and creating some sort of bioenergy. So that's the plant I visited in Punjab. And here's some more photos. The two in the middle is an Eli power plant in the UK. Now it burns 100% cereal straw, 38 megawatts, about 200,000 tonnes of straw a year, and pull it all from within a 30-40k radius. And that's a really great, viable profit for farmers too. They get a bit extra for their straw. And I went and saw it just purely for the logistics and see how it could all work. You couldn't just simply put rice straw into that system. It wouldn't work. The technology needs to be adapted, but it was fantastic to see it was occurring, and the plants opening up. There's a plant opening up about 100 k's down the road the week after I left, so they were continually evolving, which is good to see. And the one in India, it was good to see, but there are some things we can build on from that. So, my recommendations. Viability of bioenergy in Australia needs to be further investigated. As I said before, there is really big potential for this if we can look at some sort of funding from outside sources or government. On a side project, there is enormous potential for rice hull utilisation. The reason rice hulls can be so effective, particularly in bioenergy, is because they're all very similar in shape, size and quantities of everything in them. Rice straw or normal straws, you might get 65% efficiency burning out of them. Rice hulls, because they're so uniform in shape, you can look at about 85%. I actually did some calculations, and the rice industry, we've got 3 mills across the industry, and they basically sell on their rice hulls however they can, but it actually almost costs them money to get rid of them. And I calculated if they were to burn them and produce electricity, it's $23 million worth of electricity that's sitting there that are basically putting out bills. And the other thing is, their electricity bill annually is $22.78 million to run the mill, so it kind of lines up quite nicely. I've had some discussions with growers about looking at on-farm biomass plants. And there's potential on some of those other projects I talked about for those savvy growers that can look at it in some sort of niche market. So that's my presentation. It was an amazing trip to be able to go out and the place I went. I went to California, England, France, Egypt, Turkey, India, Philippines and home. So it was a fantastic trip, and there's some amazing things out there, so it was amazing. So thank you very much.